As you probably noticed, and I'm sure you know exactly, hydrogen industry is becoming a very important area, day by day, mile by mile, and watt by watt. But from who should we hear, and where exactly it stands now? These are the most important questions. What's the situation globally, regionally, and mostly in this region, in this very region where we live here in the middle of Europe? So we would like to answer these questions in the following few minutes via these presentations. Now we have a pre-recorded video message from the chairman of the Global Hydrogen Industrial Association Alliance and H2 Korea. Ladies and gentlemen, please direct your attention to the big screen. Jae-do Moon.
Good morning. I am Jae-do Moon, the chairman of H2 Korea. And I am the chair of the GIA, the Global Hydrogen Industrial Association Alliance. First of all, I would like to thank the organizers for inviting me to the V4 Hydrogen Conference, and the government, the hydrogen industry for attending the forum. I hope this conference will be an event to discuss ways to develop the hydrogen industry in V4 countries and to expand hydrogen cooperation with many countries around the world. From now on, I would present the current state of the hydrogen economy in Korea and its strategy. Why does Korea pursue a hydrogen economy? Hydrogen is the purest and the most universal source of energy that humans have ever discovered. Hydrogen is a very rich element, accounting for 75% of the universe. And when used as a fuel, it is an eco-friendly energy source that is reborn as pure water. Humans have been using hydrogen as a raw material, but have recently developed a technology that can use hydrogen as a fuel, drawing attention as an alternative to break away from the use of carbon fuel, the main cause of the climate crisis. Korea rises on the same boat. If we look at the climate change report released by the IPCC, you can see that the amount of carbon dioxide generated from fossil fuels that we have been using for human development in greenhouse gas emissions for the past 20 years. Looking at this analysis graph, as a result of analyzing greenhouse gas emissions over 20 years, fluorinated gas, nitrous oxide, methane, and carbon dioxide emissions showed a steady increase. Among them, carbon dioxide emissions from fossil fuels used in industrial and power generation fields increased significantly. Through this, we believe that the use in carbon fuel is a major cause of the increase in greenhouse gas emissions. As a solution, the IPCC's UN climate change report suggests that the world must reduce greenhouse gas emissions by 43% within 8 years through active investment and technology utilization. At the P4G summit held in Korea last year, settlements from each country shared the perception that fossil fuels used by humans cause a serious climate crisis, and discussions were held to overcome this. In addition, the P4G Seoul Declaration, which recognized the importance of hydrogen, included the phrase focusing on energy efficiency and promote the use of clean hydrogen, especially in hard-to-abate areas. Now, the world believes that hydrogen will be a significant part of the future energy sources. More than 30 countries around the world have announced hydrogen strategies until last year. It is expected to increase to more than 40 countries by this year. As such, many countries around the world regard hydrogen as the key to future energy transition. Then let's take a look at Korea's hydrogen economy implementation strategy. First, I will explain what is going on for the transition to the hydrogen economy in Korea until recently. Korea has established systematic policies to revitalize the hydrogen economy since 2019, and many policies are currently being implemented. In January 2019, Korea announced a hydrogen economy roadmap, which is the basis of hydrogen policy, and established a hydrogen technology development roadmap and the hydrogen safety roadmap. In February 2020, the world's first hydrogen law was enacted, and a basic law was aimed to foster the domestic hydrogen industry. In December of the same year, hydrogen declared to achieve carbon neutrality in 2050, which became the core of the energy conversion policy. In November 2021, the basic plan for implementing the hydrogen economy in Korea was established. Now, let me tell you about the current state of the hydrogen economy in Korea. Korea is pushing for a transition to a hydrogen economy for carbon neutrality in 2050, and is creating hydrogen ecosystem to revitalize the hydrogen industry. Currently, about 22,000 hydrogen cars are supplied and operated in Korea, with 132 buses and 20 taxis in operation. In addition, 162 hydrogen refueling stations have been built and operated across the country, and about 250 stations are expected to open by this year. Fuel cell power generation is operated at 53 sites in Korea, and about 790 megawatts of power is produced. The following is the current status of the hydrogen industry being promoted by local governments in each region of Korea. As you can see here, Korea is promoting hydrogen industry-specific projects such as hydrogen-related cities, hydrogen production clusters, R&D specialized cities, and hydrogen mobility clusters. There will be more business opportunities in the future, and a visible hydrogen society will unfold by 2030. To this end, Korea is preparing to expand this hydrogen ecosystem. The development of hydrogen cars is planning to expand to various mobilities. It is also promoting mixed power generation of hydrogen and ammonia in carbon-free electricity production. In order to reduce industrial carbon fuel, we are developing hydrogen fuel use methods in steel, cement, and petroleum processes. In addition, it is promoting the establishment of an overseas supply chain of hydrogen required for the sustainable growth of hydrogen industry. To that end, we plan to expand our hydrogen infrastructure. Korea has the world's best technology for hydrogen cars, and based on this, strategy for developing hydrogen mobility was created. Korea plans to expand its application to mobile mobility such as trucks, trams, and ships, not limited to passenger cars and commercial vehicles. To this end, it will focus on improving the performance of hydrogen mobile fuel cell systems and securing economic feasibility by 2030. In particular, I would point out that technical cooperation is being promoted between Korea and Czech companies to establish a hydrogen mobility ecosystem. A great technological synergy between the companies is expected. In Korea, there are many companies with excellent technologies such as hydrogen charging and hydrogen distribution, including Hyundai Motors. I hope that international cooperation in the hydrogen industry with V4 countries will be actively promoted in the future. We are going to expand the hydrogen supply chain to move into the hydrogen economy. To this end, we plan to expand the supply of hydrogen through demonstration of hydrogen incorporation by utilizing natural gas pipelines nationwide. To this end, we'll expand the construction of hydrogen pipe networks around the hydrogen production and transportation areas. By 2025, it will be based on hydrogen ports, hydrogen cities, and industrial complexes, and will be connected to the LNG pipeline by 2030. And by 2050, there will be a piping network centered on 4 major metropolitan areas across the country. In addition, the construction of hydrogen refueling stations and hydrogen production bases will be accelerated to expand the supply of hydrogen mobility. To this end, it plans to secure a nationwide hydrogen refueling network by transforming it in the form of a complex refueling station using existing gas stations or LPG stations. Let me explain Korea's hydrogen utilization strategy. Korea plans to gradually reduce existing coal-powered power plants with a goal of carbon neutrality and plans to utilize hydrogen. First of all, from the middle of 2020s, fuel cell power generation facilities and ammonia mixed systems in coal power plants will be expanded. The ammonia blending method of coal-fired power plants is planned to operate 20% of ammonia by 2030. In addition, based on the goal of commercialization by 2050, through the development of hydrogen generation gas turbines, we will promote carbon dioxide reduction by increasing hydrogen utilization in the industry. It is also planning to expand the use of hydrogen energy in steel, petrochemical, and cement industries that emit a lot of carbon. For example, the steel production process will establish a test site for hydrogen reduction process of 1 million tons by 2030 and expand it to 3 million tons by 2040 and completely convert existing furnace facilities to 100% hydrogen steel process by 2050. In addition, the petrochemical process aims to develop a process that replaces heavy oil, the fuel of a petrochemical process, with hydrogen by 2030. As mentioned earlier, Korea is actively promoting to establish a network to introduce clean hydrogen from overseas in the mid to long term. Korea is expecting to establish 40 stable overseas hydrogen supply chains by 2050, encompassing both blue and green hydrogen in various. A hydrogen port construction plan is also being prepared for this. The number of hydrogen ports will increase from 2 by 2028 to 9 by 2040. In addition, hydrogen production and the infrastructure construction in hydrogen import ports will be promoted. Lastly, I would like to introduce the Global Hydrogen Industrial Association Alliance, GR, which was recently established to promote global hydrogen cooperation. H2 Korea, together with 17 hydrogen associations in each country, launched the GR in Seoul to promote international hydrogen industry cooperation. The purpose of GR is to promote the growth of a global hydrogen industry and the expansion of the international hydrogen market by revitalizing private global hydrogen economic cooperation. Through this, it will promote the transition to a hydrogen society and contribute to overcoming the global climate crisis. The organization will play a pivotal role in promoting private international cooperation with the 18 hydrogen industry associations. Please support and join us in the initiative of ZEA. Thank you for your attention.
Thank you very much for the applause. And now we will break this global outlook and global analysis what's going on, analysis of what's going on in the hydrogen industry with a Hungarian project, ladies and gentlemen, because in this conference we would like to focus on the mobility mainly. So in the next few minutes you will hear about the Gold Iron project, zero emission buses and hydrogen powered drone development in Hungary. Ladies and gentlemen, please welcome the CEO of the High Hybrid Energy Limited, Dr. Akhtar Navid.
Good day, everybody. It's my great pleasure to be here to represent a Hungarian company, Goldi Mobility. And today I will be talking about mainly the project which we are leading for the last 3 years in this country. And as an introduction, my name is Navid Akhtar and I'm the founder and CEO of High Hybrid Energy. So I'm based in Scotland. So I traveled from Scotland today. And just to highlight the name of the company, if you look at the High Hybrid, the reason why I have chosen this name, basically, if you see, in my opinion, the hydrogen is best united as a hybrid energy sources. So take an example of hydrogen used in a green hydrogen production. So hydrogen is dependent on the renewable power plants. So that's one example. If you look at any of the mobility applications, look at the buses, cars, they always rely on batteries. Doesn't matter how big it is or how small it is. You cannot run a single fuel cell, separate fuel cell to power a mobility application because you need to deal with the dynamics. So the idea here basically, so today I will be, why I'm highlighting this, I would be including some kind of slides to discuss the combination of mobility with battery electric and the hydrogen applications. So moving on to the next slide. So who am I? I thought I would try to give a background, what I have done in the past in the hydrogen industry. So I'm working on hydrogen and fuel cells for the last 21 years. The very first project in hydrogen started in Pakistan, from where I originally belong to. And this was the project straight when I came out of the uni. I'm a mechanical engineer, straight coming out of the uni. I was lucky, to be honest, that I didn't knew that after 20 years that hydrogen would be a big thing. So before this project started, this was the first of its kind in my country. Then I did my master's in Germany in renewable energy. Again, everybody now see renewable energy is a big thing. And this decision was made, roughly speaking, 17, 18 years that I would be doing my master's in renewable energy. My PhD was in fuel cells from UK. And during my PhD, I did the world's first modeling and experimental study during my PhD thesis. I worked for a British company, AFC Energy. And during that project, I was working on the world's largest tertiary alkaline power plant with that company. Leading to the next one, which is the Hungarian fuel cell bus project. So again, this project started in 2019. This is the first of its kind when we started, and still, to my knowledge, it is still the first of its kind in Hungary. The Gold Line project, basically, which includes different variants of the zero emission buses. I am also proud to be the founder of the world first International Hydrogen Aviation Conference. So this step I took roughly 2 years ago when I realized that everybody's talking about the planes, the buses, the cars, the trucks, the trains as well, and also the ships. But there was hardly anything done on the aviation side. So I decided to set up this world first forum. And this forum basically is running this year's third event. Next one, I'm again lucky that my country connected me last year in 2021 to lead the first of its kind in Pakistan, a 400 megawatt green hydrogen project. So I am working on that project as the CTO for the company. Moving on, yesterday it was again a lucky day for us. We signed a joint cooperation with a company to set up the first Hungarian fuel cell system assembly plant, which means we will be working together with a partner company. And the idea behind is that we will procure maybe only the fuel cell stacks, and the whole balance of plants assembly would happen locally here. And I would just use my own last 20 years of experience bringing together with all the partners into that game. And you never know what would be my next first, but I really like to be the first. Okay, so in terms of the projects, so as I mentioned, we are engaged in many projects, and I would go into details in the coming slides. So basically, our current focus is to lead all the relevant projects into the mobility area, coming from trucks, buses, ships, planes, and also to the trains as well. The Gold Line project. So this project started in 2019. As I said, within that project, what we were looking for, we decided to start this project from a fuel cell point of view right in the beginning. But later down the line, we were talking to the local government people and also some partners as well. And we came to the conclusion that it would make sense for us to include the battery electric buses into our project portfolio. The reason behind was basically we understand that Hungary is still lagging behind in terms of the infrastructure, because there's hardly, to my knowledge, there's hardly one refilling station in Hungary right now, which started, I think it's last year. And there's much needs to be done. So what we did basically, why not we include the battery electric buses into the project? And as I mentioned before, hydrogen is best suited in many of the applications when it is hybridized with other energy systems. And that's the logic behind. So for the phase 1 project, we set up this zero emission bus family, which means we were looking for all the different combinations of battery electric and the fuel cell buses. Plus, we were also looking how to charge if it is a battery electric, and how to refuel if it is a hydrogen fuel cell bus. For phase 2, the idea behind is to have a local assembly of the fuel cell engines. So that part, as I mentioned in the beginning, yesterday we signed a contract with a company to do this local assembly, again, the first of its kind here, and charging station assembly as well. Phase 3, which would happen later down the line. And the idea is we will further go into the detailed drivetrain assembly, which means not only focusing on the fuel cell engines, but taking care of the battery, for example. There is a DC-DC parts in the fuel cell drivetrains, and also there are electric motors as well. So we are linking together and talking to the relevant suppliers who are interested to work together to set up the whole drivetrain. So it's a long-term vision. And what we did again later down the line, somewhere in 2020, we decided to include hydrogen-powered drone into the project as well. This was again coming from my own kind of knowledge that we need to also include aviation, because aviation is going to become a big thing in the coming years. And as it was pointed out by the earlier speakers, that by 2035, Airbus has announced basically they are powering the first flight, which would be powered by hydrogen. So just give you a background on the electric drivetrain. So if you look at the difference between a battery electric and a fuel cell electric, this is quite, you can see there are quite synergies between these two drivetrains. The only difference is basically you have to, once it is a electric drivetrain or a battery drivetrain, you have to add a hydrogen tank, which is an extension, and also you have to bring a fuel cell system, which requires air compressor and some cooling mechanism. So in fact, the battery electric and the fuel cell electric, they have a lot of synergies between, which is many of the components can be easily shared. Like you can see, battery is the same in both cases. It could be smaller or bigger depending on the drivetrain. But battery, the electric motor, the inverter, these three things are common in both drivetrains. The only addition is the hydrogen tank and the fuel cell side. So if I move to the Gold Line project, so as I mentioned, there are basically four variants of the different drivetrain assembly in that. So our idea was to consider 12 meter and 18 meter as the fuel cell bus, and the smaller, which is 8.5, and the 12 meter is a battery electric bus. The reason behind, I think many of you already know, that when you look for the battery drivetrain, there is a tipping point when it comes to the range, because the the longer you want to drive, which means a long haul drive, that the battery becomes quite heavier and heavier. And there would be a point it doesn't make any sense to use batteries. That's why, if you look at the ships, for example, specifically to the planes, the long haul planes, once you go to, let's say 200 or 300 miles, then you have to only look for hydrogen as a solution, because battery would not work there. So our analysis, we did quite a detailed kind of economical and also the technical study on that to find out where would be the tipping point between these drivetrains, and then decided 12 meter is the ideal kind of tipping point. So if we are below that, then we can live with battery. And if we are above 12 meter, then the only solution for us, which makes sense from a driving range, it would be the only solution would be the fuel cell bus, and that's the tipping point. Now, looking at the pictures of the bus, so you can see, I don't know, many of you may not have heard about that, but the reality is these E9 and E12, which are the battery electric buses, they are in Hungary right now. And the H12, which is a 12-meter fuel cell bus, this has been recently completed with a cooperation between Hyzon Motors and us. And many of you know Hyzon Motors is a big player when it comes to the fuel cell engines. So these guys are supplying the engines to those bus families for the 18-meter fuel cell bus and also to the 12-meter. The 18-meter is the one which is in a development stage. The other buses are ready. With respect to the 18-meter bus, if you can see, I'm just giving you a highlight on how the drivetrain look like. So you would see on the top of on the roof of the H18 bus, there is a air conditioning, and then next to that there is a battery, and you can also see the hydrogen storage tanks. They are located onto the roof, and there are nearly 12 hydrogen tanks which are powering this bus. And again, we have decided to extend the range as much as we can, but there is a limitation how much load we can put onto the bus. The good thing about this bus is, again, to my knowledge, as I said, from my experience looking at this industry, what I found, this would be, correct me if anyone can challenge me, this would be the world's first plug-in hybrid 18-meter bus. It is a 18-meter bus, but it is not only fuel cell, it is a plug-in hybrid. So plug-in hybrid means you can charge it, and by charging this bus, you can drive down to, let's say, 50 kilometers to reach to a nearby refueling station, and then you can refuel a hydrogen. So this combination of a plug-in means you can drive both on electricity as a battery drivetrain or as a fuel cell as well. And on a 18-meter, to my knowledge, no one has done that. So moving on, I think it's less of a relevant for this conference, but as I mentioned, I like to be hybrid with hydrogen. So this is the electric chargers which are used for our battery buses here as well. For the hydrogen refueling station, what we are looking here, we are, as I mentioned, our 12-meter buses are ready. The 18-meter are still in production stage, and we are looking what happens when the buses, comes to Hungary, for example, and the 18-meter, if we want to refuel that, which needs quite a lot of refueling anyway, we need to find out, do we need to drive to Budapest, for example, from Reykjavik, or is there anything nearby? If we want to drive, I don't know whether we will be able to come back with the same single charge, depending on the distance between. So that's why we are looking some other solutions, local solutions, where we can find some kind of mobile refueling stations. In this case, it is a very small station where you can refuel up to 200 kilogram a day. And this could suit like 4 to 5 buses a day, basically. So if you think about each bus carries 40 kilograms, so you can easily refuel that. So idea behind is we are in a cooperation, and today we have a partner here. We are again lucky today. We have a partner here to whom we are discussing this partnership and finding out if we can have maybe a cooperation together, either as a contract or as a MOU. We will find out today. And the idea is to have our own customized refueling station for our buses. The 18 meter. So I'm going into a deeper detail now for the 18 meter. As I mentioned, it is the focus for us because it is a very innovative kind of bus design. So within the 18 meter bus, it is a special plug-in hybrid, so FC PHEV, and this runs both on hydrogen as well as electricity. It is a M3 category low floor bus, And this is, this is in a last stage of the assembly. I will show in the later slide. And our plan is to have a full European approval for that, so that once the bus is ready, it can, it can be used anywhere in Europe. The bus is equipped with a 100 kilowatt fuel cell system from Hyzon Motors. It has a high voltage battery and a 250 to 350 kilowatt electric motor as well, 12 hydrogen tanks at 350 bar, and it has a CCS2 type electric charger as well to recharge that bus. Further detail on that bus, so I would give you the whole layout where the bus currently stands and what we have done in the past, at least past 3 years. And knowing that there were COVID challenges in our way, so there has been slight slippage in the project, but we will continuing working with our partners to make sure that it is on track. So we started the bus design from a layout design and then moved to the chassis body and a structure design. We also completed all the drivetrain component purchasing. This started, I think it was last year, somewhere in the early last year. Then we completed the chassis mechanical part. So all the chassis structure was done. Body assembly was completed. We did the welding production as well. And the current status of the bus, as you can see in the pictures, that it is sitting on a paint coating stage, which means the painting of the bus body has been completed. The next 2 or 3 stages which are left is, after that process, the bus would be entering into a final assembly and commissioning stage. And once this assembly and commissioning is done, it has to be trialed to check if there are any malfunctions in the operation, which means we would be doing the inspection and debugging of the drivetrain. And finally, we would apply for the EU homologation, making sure that everything is ready to bring and then run this bus in a real life environment in Hungary to begin with, and the other European countries afterwards. The other project you may have seen in the exhibition hall upstairs. If you have not, please, I suggest go upstairs and you will find our hydrogen powered drone there. So the hydrogen powered drone again is another extension to the mobility projects which we were looking apart from the buses. In this case, we are targeting this drone to be locally assembled in the coming months. So at this stage, it is a fully assembled system. But the idea behind is to have the hydrogen tank, which is sitting on the top of that drone. We would like to replace that tank to become, find out a much lighter, which can increase the range. So currently we are talking, roughly speaking, 4 hours to maybe 4.5 hours kind of flying range. But our idea is to have much thinner, much lighter, either type 4, for example. This is a type 3 in this case. Type 4 tanks would be much lighter. And then going forward, there is a lot of R&D ongoing. People are talking type 5 as well. So we can think about, how we can further extend the range. That's one consideration. The other consideration is we are also looking, based on our expertise on the fuel cell side. There is a fuel cell in this drone, and we are looking how we can get a better kind of, much lighter fuel cell, which can give a much better power in terms of the dynamics of the flight. So these are the two active areas to look at, and we are in a continuous touch with our partnership to find out how we can achieve these two things into a best kind of status. The third thing, which we are looking as a European homologation as well for the whole system, which means all the components which are in the drone system, they are fully certified, and that's why we are working very closely how we can get certified. Like the fuel cell system should be certified, the hydrogen tank should be certified, so that we can run these trials to other part of the world. The same thing as you can see in the hydrogen powered drone. Further details. So on the left hand side, if you can see, is the basic operational chart of the fuel cell, how it gives the instructions to the hydrogen powered drone. So you have a battery, as I mentioned before. Any mobility application, when you are looking to fly anything on fuel cells, you always need a battery. So there is a battery there, and this battery is working together with the fuel cell, and the fuel cell is basically checking the required voltages, required currents to power at a suitable height. There is a hydrogen tank as well in this drone, which is giving you how much pressure is there, because if the pressure is running out, you are losing your range. So all together is working on that case. Another project. So I'm slipping now out of the Gold Line project, just the last 1 or 2 slides. So as I mentioned before, when we talk about the mobility or any hydrogen related projects, anything which consumes hydrogen, now it came to my attention. It was, to be honest, it was last 2 years, 2020 maybe onwards. Everybody start talking green hydrogen. I've never heard, if I look back my history, 2001, nobody knows even what the colors are. Up until 2016, 2015, nothing about any colors. And suddenly after that, within the last 2 years, every project, if I go to any news, green hydrogen, green hydrogen. So what we did, that's the same thing. So the initiative kicks on because everybody understands Saudi project, NEOM project is the claimed to be the world largest project for green hydrogen production. So we came up with the same version of the Saudi NEOM project. It is the fourth of its size, roughly fourth or fifth of the size of the Saudi. So Saudi guys are talking 2 gigawatt and we are talking a 400 megawatts, so one fifth of that. And the idea is very similar. Make green hydrogen in a renewable rich location in Pakistan and via the solar and the wind, because the city I belong to is Karachi. And when I am there, the temperature could be as high as 45 degrees Celsius. And you can have 365 days of solar. So it means you have an enormous solar energy there. Likewise, you have the wind there. So the idea is to connect the solar and the wind to have the green hydrogen produced. Once the hydrogen is produced, then you look where you want to transport. So we are looking very nearby partners. So China is the biggest partner for us because we have the borders with them. And in fact, in this project, Power China, one of the leading player from China, is the partner for that project. So Power China from China, they are engaged. You can see in this picture as well. So this picture is basically from a royal prince in Dubai. So we have engaged this royal prince into the game, and he's owning 70% as a joint venture into that project. It's a big kind of thing for us as a project for a green hydrogen. You need some kind of investment because it's a big investment project. So this Dubai Sheikh basically, so he's owning 70% of the investment of these studies which we are currently doing. So we have completed the pre-feasibility, entering into the full feasibility. And these guys from Siemens in this picture, you can see they are discussing in this picture, for example, what kind of electrolyzers could be suited for that project. Idea is to make green hydrogen. And then I'm linking now this to this gold line project, because once we are powering our buses in the coming years, maybe the buses will move from single prototypes to 10 of them or 50 of them. Once we are increasing that, we need more hydrogen. Then people would come to us and ask, Naveed, can you tell me is it a green hydrogen? I don't know, because there is nothing green hydrogen right now. And many of the European people, they are still using fossil fuel on the background and give you a gray hydrogen. So what we need to do, we need to sell this and then bring this hydrogen and then connect to the Hungarian kind of infrastructure or to other European part to mobilize this kind of green hydrogen connections to all these kind of projects. So that's the intention behind. And the last one, so that's again a snapshot from my last year second round of the International Hydrogen Aviation Conference I mentioned. And as I said, I am moving to the third round this year. And I'm really, glad to see many of you are really interested in hydrogen. So this is my invitation to you. Please come to Scotland. It's a beautiful place to move around as well, to see the natural scenery, and plus to have the look at the hydrogen use in aviation, what we are doing. Summary wise, so phase 1, phase 2, as I mentioned, these two phases are almost in the stage. So phase 1 is nearly complete. Phase 2, engine assembly, yesterday signed contract, charging stations are happening. And now we are moving to the phase 3 kind of initial discussions. So looking how we can, bring other players into the game for a full drivetrain kind of assemblies. So talking to different partners. For refueling suppliers as well. So as I mentioned, there is a potential partner today here, and our plan is to discuss with them. If they are happy to engage with us, I will open the dialogue and set up this kind of joint venture or a MOU or maybe a partnership, depending on how the discussion goes on. The last point in this is basically once we have done this part, moving to the last phase, we are looking for other extension to the project. Not only looking and stopping at the fuel cell side, but looking the other part of the hybrid drivetrain. And that's the idea behind. With this, I will end my presentation and thank you for your kind attention. If you have any questions, I'm here to ask, please. Thank you.
Thank you very much, Naveed. I mean, we can make it in the lunch break if someone would like to connect you personally. Thank you very much for your words and showing us this not local but truly global project. Thank you very much. Did I see these buses on the Debrecen Drive or no? Was it on Debrecen Drive? No, because on the northeastern part of Hungary we have a huge, let's say, event on mobility, and we have the latest technology there for the spectators and the people. Anyway, thank you very much. Great project. And to close this part, ladies and gentlemen, we would like to show you a video message from the representative of the NIDO, which is for the New Energy and Industrial Development Organization. So, ladies and gentlemen, please welcome Imazato Kazoyuki.
Okay, let's begin. Firstly, I'd like to introduce about NEDO itself just briefly. NEDO is one of the largest public funding agencies in Japan with two main missions that consist in addressing energy and global environmental problems and enhancing industrial technology development. While our activity fields are widely spread to a variety of technologies, such as robotics, AI, IoT, or materials, as well as support to startups. One of our main activities is related to energy system. In this context, NEDO have been supporting hydrogen-related technologies for a long time. NEDO has 6 overseas offices, and our Paris office covers all over Europe. Historically, we have had some demonstration projects in Europe, such as in Lyon in France, Manchester in the UK, Lisbon in Portugal, Ljubljana in Slovenia, or Niedersachsen in Germany. Now, 2 projects are on the stage of feasibility study to build up the demonstration project. Both projects are related to the hydrogen technology. As the latest one, last December, a German energy company, RWE, and Kawasaki Heavy Industry announced that they started building the world's first 100% hydrogen-capable gas turbine on industrial scale in Lingen, Germany, under our NEDO's support. NEDO Europe wishes to implement more such projects in Europe to address energy and global environmental issues through the cooperation of Japanese companies with European partners. Secondly, I will show you the outlook of Japan's energy situation. Here is the basic background of Japan's energy situation. The left figure shows us that Japan depends on a lot of fossil fuels even in 2019. Besides, at this moment, it is very difficult to use nuclear power largely, since a part of the public opinion is afraid of it due to the accident of Fukushima nuclear plant in 2011. CO2 emissions are shown in the right figure. CO2 emissions from the energy transformation sector, mainly power generation, account for about 40% of the total energy related to CO2 emissions. It is therefore critically important to efficiently utilize hydrogen as one of the key technologies to realize a smart energy transformation. This figure is a basic scenario of how Japan can achieve carbon neutrality in 2050. In the electricity sector, we will promote low-carbon electricity by using renewable energy, hydrogen or ammonia combustion, as well as nuclear power. In the non-electric power field, we will promote more and more electrification. However, in areas where electrification is difficult, hydrogen, ammonia, and biomass will be used directly. This figure shows the direction of the hydrogen efforts. The target is to reduce the cost of hydrogen. For reducing the cost, we will proceed with efforts to expand the amount of the hydrogen used in the future. In the green growth strategy, which I will explain more detail later, the target amount of hydrogen will be used in 2030 was set as a maximum 3 million tons. And the target for long term was also set as 20 million tons in 2050. In order to realize such expansion of the usage of hydrogen amount, we will do our best not only for supply side, but also the demand side. As for the hydrogen supply, we will utilize hydrogen from overseas and the domestic renewable energy hydrogen from 2030. For this reason, we will proceed with technological development and scale-up. On the usage side, we will first expand fuel cell mobility. From automobiles, we will promote the use in ships in 2030 and in aircraft in 2050. In terms of electric power, hydrogen power generation will start in 2030. In the industrial field, we aim to put it into practical use by 2050. We will also promote the introduction of the decentralized cogeneration. In any case, technological development is important. Especially in the next 10 years, we will actively invest in the technological development in order to gain a lot of knowledge. Next, I will explain NEDO's activities on hydrogen, especially about our flagship project, FH2R, the so-called Fukushima Hydrogen Valley project. In regards to hydrogen technologies, for many years, NEDO has taken a step-by-step approach, has been supporting Japanese companies through funding and project management. In 2009, we launched our residential fuel cell project on the Japanese market, and 400,000 have been installed since then. This makes Japan the #1 country in terms of residential fuel cells installation. By improving this technology, Toyota has launched the FC vehicle Mirai in 2014 for the first time. To support the enlargement of the market in 2015, Toyota made their patent on FCV open to everyone. As the final step, hydrogen from renewable energy will soon be generated widely, so it's a good time to move into the new age of hydrogen. Here is the history of hydrogen-related technologies by NEDO. In order to produce large volumes of hydrogen from renewables and to develop applications widely, global collaboration is very important. This is why NEDO has recently organized the Hydrogen Energy Ministerial Meeting every year since 2018. In the last year meeting, 18 ministers from various countries joined. The last 2 meetings were held online because of the corona pandemic, but I do hope that this year meetings can be held physically in Japan. This slide shows how the cost of the residential fuel cell was reduced gradually by the Japanese government support. After the commercialization of the residential fuel cell NFM in 2009, the Japanese government had quickly started the subsidy scheme to accelerate the development of NFR. As a result, more than 400,000 residential fuel cell units have been installed by 2021, and the price of the unit has gone down less than one-third of the price in 2009. After the commercialization of FC vehicle in 2014, the number of the FCV has not been increased dramatically. For further development or acceleration, NEDO and the industrial side thought that further performance improvement and cost reduction were required for the spread of FCVs. And FC would be installed not only in passenger cars, but also in heavy-duty vehicles such as heavy-duty trucks in the future. So recently, NEDO has promoted R&D projects of elemental technologies that enable to be operated under high-temperature environment to improve the durability, to contribute to the cost reduction of high-pressure hydrogen tanks, and so on, aiming for its practical use after 2030. FH2R demonstration projects will be conducted until 2023 by NEDO. Project members are Toshiba as project manager, Iwatani as hydrogen supplier, Asahi Kasei as electrolysis maker, and Tohoku Electric Company as an electricity operator. The project purpose is to develop a hydrogen utilization business model that optimizes the exploitation of hydrogen as both a commercial commodity and as an energy. Technically, it aims to realize a new control system that optimizes hydrogen production and supply with demand focusing for hydrogen. The project size is in Fukushima Prefecture. It is just 250 kilometers away from Tokyo. The site is always open for anyone to visit. Therefore, when you come to Japan after this corona pandemic, you may please consider to have a short trip to visit Fukushima Hydrogen Valley by simply requesting to us. Here is an overview of the project site. The total area is 22 hectares. The center premise has an electrolysis system which is powered by 20 megawatt PV power generation. There are hydrogen storage and supply facilities, and then hydrogen is carried from this facility by tank lorry for local usage. These facilities were completed in March 2020, and the demonstration will run until March 2023. This is inside of one of the facilities, where you can see the electrolysis conducted by Asahi Kasei. A maximum of 10 megawatt of hydrogen is produced by 20 megawatt of PV power. This means that 180 kilograms of hydrogen will be produced per hour, which corresponds to the complete hydrogen refueling of 30 to 40 Toyota Mirai models. We're going to increase the capacity of electrolysis up to 40 megawatt in the near future and possibly to 100 megawatt on the long term. This facility has many safety devices designed to avoid explosion. Many experiences gained from the long R&D history taught us how to reach explosion-proof and earthquake-proof status. Therefore, when hydrogen valleys will be deployed in many years, safety must be guaranteed, especially in Japan, that is a land of earthquakes. As a consequence, I believe that Japanese technology would contribute to realize the top-level safe hydrogen society in various countries. The renewable hydrogen supplied from this FH2R is used in various situations. For example, we used during the Tokyo's Olympic Games last year to show the future of the society with hydrogen. On other occasions, this hydrogen is used in the famous music festival or hydrogen colorways and so on to raise the public acceptance of hydrogen. As you may already know, in October 2020, the Japanese government declared its ambition to reduce greenhouse gas emissions to net zero by 2050. To achieve this goal, the Ministry of Industry (METI) formulated the Green Growth Strategy through achieving carbon neutrality in 2050. To support R&D activity, NEDO started the Green Innovation Fund program. The fund size is over 14 billion for 10 years, which includes hydrogen R&Ds. To realize the net zero emission objective, NEDO is responsible of the huge fund called the Green Innovation Fund, as I just explained in the previous slide. By using this fund, we have started new hydrogen projects since last year. In these projects, we will implement an hydrogen or ammonia value chain with overseas partners. We will realize the scaling up of hydrogen production in domestic areas, and we will expand and use applications with overseas partners as well. Lastly, the current Japanese Prime Minister Kishida is very keen on tackling global warming. Therefore, a new policy called the Clean Energy Strategy is expected to be published this June or July. In addition to the previous strategy, this one will further strongly promote the realization of the hydrogen-based society that counters global warming, especially focusing on green transformation on demand side. Here is the conclusion for today. As I explained to you, in order to realize carbon neutrality, hydrogen is a key technology, and Japan has been strongly promoting it. However, it has just started market penetration, so we need to expand the application and to improve technologies for the future development. And finally, our goal is to realize a low-carbon energy system, and for that, NEDO has a strong interest in hydrogen economy Europe. So I am very happy to make a good communication with all of you taking these great opportunities. Thank you for your attention. Thank you very much. Kusunume.
Wow. Arigato, yeah. It was in Hungarian at the end. Köszönöm, thank you very much. The organizers just asked me to tell this very important information about the NEDO, which you just heard about. That the NEDO is also financing hydrogen projects in Europe, ladies and gentlemen, and its conditions are comparable to that of the EU funding systems and mechanisms. So Japan may be far away physically and geographically, but the helping hand is very close to Europe. So please contact the NEDO.